recorded. Yeah, then the others will know. Yeah, sure. So yeah, nearly cover everything, and it will definitely not have the computer experiments like calibration. We will definitely not having that. We will definitely have calculations.
Right.
And which means like MATLAB or other like coding like software will definitely help you to do this kind of calculation, right?
Okay. So is it 9:30 a.m. and 2 hours?
Yes. So as what I mentioned in the class, it's like it is a 6 hours window, but to make it fair, so I'm asking students if they can't start from 9:30, and they need to let me know prior to the exam, and then it starts at 9:30, and it will be 2 hours for answering the questions, 10 minutes to 10 minutes to like read the questions, and 10 minutes to download the paper, and another 10 minutes to upload your answers. So it's like totally 2.5 hours from 9:30, 2.5 hours, and that's the very like deadline. So, I mean, it's not a strict deadline, but every student submit their questions after that deadline. I will definitely give them an interview after I mark on the paper.
Right.
This is just want to make a fair like examination. So hope you understand about that. Yeah.
Okay, got it. Thank you.
No worries. Yeah. So any other questions?
Not from me. I don't think.
Okay. So if you don't have any questions at the moment, you don't have to like wait here. So I will record everything. Then if you want to listen to what others ask, then I will upload the video. Then you can have a look. All right.
Right. All right. Thank you, sir.
No worries. No worries. See you. So I also have like another 2 time for the consultation. So if you like have further questions, then you can call back again.
Okay. Thank you.
All right. See you.
Hello, Dr. Zhao, can you hear me?
Hey, James, how are you doing?
I'm doing very well. How are you?
Good.
That's good. Do you mind if I ask a couple of questions?
Sure. No worries. Keep going. Yeah.
Cool. So I've just been studying linear discrete time systems this morning. And I've been looking at the example we did in class where we had the natural resources and the 3 different processes. Do you remember that example?
Yes, I think so. Yeah.
And then in forming the state space equations, of the model, sorry, for the B matrix, I've got a column vector of 1, 0, 0. However, I'm not sure if that's like I'm thinking if there's more than one input.
Yeah.
Does the top the first element of the vector relate to the first equation for x1 at k plus 1, and then this? Okay.
Yeah. So I think your question is something about in the example it's like there's only one like inputs, right? Then you're thinking if you have multiple inputs, right?
Yeah. And so if there was an input into say the R, I don't know what R is here, the products in R, if there was an input into there, would you put that as the bottom element of the vector?
Let me show you an example, then
sure. Sorry, I haven't got a camera that I could use at the moment.
No, don't worry. So you can, if I share the screen, you can see that, right?
Perfect. Yep. It should pop up when you start sharing.
Let me do it first and see. Let's see which one I'm sharing. Yeah. So can you see the paint window? Okay. Yeah, great. So I think in your in the example, it's like 0, 0, 1, and times u, right?
Yeah, but I've
Whatever,
actually
but
got,
I mean, yeah, something like that. So
yeah, yeah,
if you have u1 and u2 and u3, suppose,
yep,
right? And then suppose your x1 k plus 1. Sorry, it's my writing is really bad.
no, that's all right. It's very difficult with a
Equal to
mouse.
something something something
Yep,
plus u1, suppose, right? And x2 is something 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 plus 2 times u2. Let's say something like that, right? And x3 is something 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 minus 3 times u3. Is that the question? How we
yeah,
can like formulate it, right?
yeah.
Okay.
So in that vector that you've got, the column vector that you've got above, would you have,
Yep.
would the solution be 1, 2, minus 3?
Okay. So in this case, first you have like 3 variables in the input.
Yep.
You need to make it as a column vector as well,
Yeah,
like similar to the step vector, right? So that is u is equal to u1, u2, and u3,
Yep.
right? And then what is b? That's the question, right?
yeah, yeah.
Okay. So in this case, I'm writing the first, then I calculate it, then you know why is that, right? In this
Sure.
case, the B matrix is something like this. Sorry, that's 0 minus 3.
Oh, it's going
This
to be
is
a
the B
3 by
matrix.
3. Okay.
Yeah. Why is that is, if you calculate B times U, what you get, right? Then what you get is this row times this column. Then that's U1, right? And this row times this column, then it's 2 times U2.
Yeah.
Right? And this row times this column is minus 3 times U3.
Yes, that makes so much sense.
Right?
Okay.
Right. In your case, because you only have one input, then the dimension of the input is 1 by 1. All right, and the column, the dimension, I mean the dimension of the number of columns of B matrix is the same as the dimension. It's the same as the number of rows of the input.
Yeah.
Right. So in the previous case is 1 by 1, then that's a 3 by 1, and the rows, the number of rows in B is equivalent to like how many variables you have in the state.
Okay. I'll just put that down here. Rows equals state variables.
Yeah. So in this case, you have like 1, 2, 3 variables in the state, and 1, 2, 3 like variables in the input. And then the B matrix is 3 by 3.
Yeah. And so if we had 3 state variables, but only 2 inputs, what would that just be a 3
That
by
will
2?
be a 3 by 2. Yes. 3 by 2.
3 by 2. Okay.
Yeah.
Cool.
Because it's B times U, right?
Yeah,
And the
and that
number
has
of columns of B must be the same as the number of the rows in U.
Yeah, and that's why in the lecture notes you've got a note saying that they've got to be dimensionally accurate or something. What did you say?
Yeah.
Cool. Okay, that's very, very helpful. Thank you so much.
No worries.
Do you know if are we supposed to be able to view our marks for the previous assignments, or are you waiting until after the exam?
I'm trying to make it before, but not quite sure if I can make that. But you do.
Lots to do. Yeah, no, that's okay.
I do think you don't need to worry about the marks on the project. Don't worry about that. You've done a great job. So
nice to hear. Oh, thank you. Yeah, I really enjoyed the subject. It was nice to have a bit of freedom in how we sort of decided what to do with the project. That was really cool.
Thanks.
All right. I may just go on mute, and then that way I'll stay in here until 11, and then if I have any more questions, I don't have to reconnect.
Okay, you don't have to like actually be here. So I'm recording everything. So
Oh, okay.
yeah. So if you don't have questions, that's fine. If you have questions, just jump back. Then if you want to listen to the others' questions, then I mean I will record it in the video. I'll upload it
Oh, great.
in the comments.
Yeah, that's very helpful because I know a number of people I've spoken to, they've got work meetings or just work in general at the times of these consultations. So yeah, if you upload the video, they can still appreciate that. That's cool.
No worries.
All right.
No
Thank you
worries.
very much.
No worries. No worries. See you. Bye.
See you later.
So please do make sure you make the MATLAB ready. So if MATLAB is the one that you're familiar with and you want to use it to do some calculation, then try to make it ready.
Yeah,
because
and just we can include screenshots and that sort of thing of our code and the
better
results.
not including screenshots. You just write it. You just write the necessary equations, necessary progress in the answer.
Okay.
And then when it requires calculation, you can use MATLAB to help.
And just put the solution,
So
the answers.
Try not to do some screenshots or directly copy codes. No, try not doing that.
Yeah, no problem. Okay.
So
and
MATLAB
should we
is something to help you to do the calculation.
Okay, so it's just like if we were going to use a calculator, you just put the answers that it spits out. Okay.
Yeah, put the answers, but better to have the process there as well. So necessary equations and process and how you can solve that question, and then the last step will be the answer, right? The numbers. Then you can use MATLAB help.
Okay, great. Thank you very much.
No worries.
Go today.
Yeah, no worries. Yeah.
With just looking at the linear discrete time system still, as far as stability, if the eigenvalue is equal to 1, I see from the slides that means it's marginally stable.
Marginally stable.
And so if the other two are less than 1, so you say you've got
it's still marginally stable. It's still marginally stable.
Okay. And what does that mean in practice?
In practice,
like in a real system,
is around. It's a complicated question.
Okay.
In reality, we try to avoid that because the marginally stable still means sometimes it will close to not stable.
Okay, sure.
All right. So in the real case, if we test the system which is marginally stable, we still try to use some feedback control to make it fully stable.
Oh, okay, cool. So you just treat it as as more of a stable system or an unstable system?
Yes, we can't say it's not stable.
Okay.
But I mean, if you run it, most of the cases, for example, we have 3 eigenvalues, but 2 of them are less. Between -1 and 1, and the other one, the third one is equal to 1.
Yeah.
That sometimes it will cause that, and for some of the time it will not be stable, but for most of the cases, the system is stable, but it's a bit hard to say.
Okay, cool, no problem.
Something like that.
Yeah. Okay, that's great. Thanks very much for your help.
No worries.
Talk to you later. Bye-bye.
All right, see you.